Alright, let's look at how to write rational functions from our graph. Alright, so let's remember we have y equals a over x minus h plus k. This is our standard form, right? So we have a, which is a vertical stretch or compression. If this was a negative, a would be a reflection. This is going to move the graph right or left. This is going to move the graph up or down. Alright, so here we go, number 10. Let's find a point on the graph. And there it is right there. Okay, we know that our vertical asymptote is right here at 1, 2, 3, 4, so x equals negative 4. We know that our horizontal asymptote is right here at y equals 0. Alright, so let's plug those into this. So we have negative 4 going in right here. We have 0 going in for k. So we have y equals a x minus negative 4, so x plus 4. And then plus 0 right here, so I don't need to write it. So we have this function right here. Now what we're going to do is we're going to need to use this point to figure out if my a value is any vertical stretches or compression. Well, this point is at negative 1, 2, 3, positive 1. So negative 3, positive 1. So now we're going to take this value, plug it in for my x and my y, and solve for a. So we've got 1 equals a over negative 3 plus 4. So this is going to be 1 over positive 1, a over 1. Okay, we'll need to multiply by 1 to get rid of the denominator. 1 times 1 is 1, so a is equal to 1. So we know we didn't have any vertical stretches or compressions, and we know there was no reflections. So my function would be y equals 1 over x plus 4. Same thing for number 11. Okay, let's look at my asymptotes right there. Vertical asymptote at x equals 1. Horizontal asymptote right here at y equals positive 2. So we know that's going in place. So we got y equals a over x minus 1, because it's a positive 1 here, and then plus 2. So let's find another point on the graph. Looks like that's a point right there. So we go over 1, 2, 1, 2, 3. So that's a point at 2, 3. Plug that in so we get 3 equals a over 2 minus 1 plus 2. So 3 equals 2 minus 1 is 1, so a over 1. We can go and move that to this side, so subtract 2, subtract 2. This is going to become 1. Same thing here, we get 1 equals a over 1, so we need to multiply by 1 to get rid of the denominator. 1 times 1 is 1, so a is 1. So again, no vertical stretches or compressions, so we have y equals 1 over x minus 1 plus 2. Alright, number 12. Okay, again, same thing. Let's look for our asymptotes. Vertical asymptote is right there at negative 2. Negative 2. And the horizontal asymptote is right here at negative 3. Alright, so here we go. Let's plug it in. We get y equals a over x minus 2, so plus 2. And then minus 3. Alright, let's find another point on the graph. Looks like that's a point right there. We went over 1, 2, 3. 1, 2, 3, 4. So negative 3 over 4. Plug that in right here so we get negative 4 equals a over negative 3 plus 2 minus 3. Move that to this side, so we got to add 3. So this is negative 1 equals a over negative 1. Multiply by negative 1 on both sides, by denominator. Negative times a negative is positive, so again, a is still positive 1. So we get y equals 1 over x plus 2 minus 3. And last one, look at number 13. Okay, number 13, we can see that the graph is different, right? This was the graph in the top right quadrant, now it's in the bottom right quadrant. So we know that's going to be a reflection, so let's double check ourselves. Let's find our vertical asymptote right there at 1, 2, so x equals 2. Horizontal asymptote is going to be at 0, y equals 0. Alright, so let's plug those in. We get y equals a over x minus 2, and then plus 0, so we don't need to write anything there. Let's find another point on the graph. Looks like that's a point right there, so we went over 1, up 1. So we're going to use that point, 1, 1. So 1 equals a over 1 minus 2. 1 equals a over negative 1. So we need to multiply by negative 1 to get rid of my denominator. Negative 1 over here. Well, negative 1 times positive 1, we get a negative 1 for my a value. Alright, so let's write our function. We have y equals negative 1 over x minus 2, and then plus 0. We don't need to write plus 0.